Hello everyone. In number 17, we're given a graph of a trig function with a positive coefficient, and we're asked first of all to find the amplitude, period, and vertical shift. Now our amplitude is our max minus min over 2, so that would be the maximum y value, which is 1, minus minimum, which is minus negative 3, all over 2. So that's going to be 2. A period is where the function repeats along the x values. So that would be like from the peak to the peak. That's a repetition right there. And so that's going to be the distance 4 minus 0. So a period is 4. Vertical shift is max plus min over 2. That's going to be 1 plus negative 3 over 2. And so that would be negative 1. Part B, we're asked to find an equation of the form y is equal to a sine bx plus c plus d. And so we have our amplitude there, which is a, but for b, we need to find the period. And the period was 4. So period is also 2 pi over b. Remember that period. 2 pi over b. So then b would be 2 pi over period, which is 2 pi over 4, which gives us pi over 2. For c, we need to find our phase shift first, so we'll look at where there would be like a start to a sine function, which would be, try to look at the first left start, which would be the x value that matches that first start, which would be where x equals negative 1 right here. So phase shift is negative 1. Phase shift is also negative c over b. We know that b was pi over 2. So negative 1 would be equal to negative c over pi over 2. Therefore, c would be equal to negative 1 times pi over 2, which would be negative pi over 2, but that was negative c, so times negative 1, that becomes pi over 2. All right, so now we have enough information to write our equation because we have our a, and a was 2, or amplitude was 2, and sine of bx, b was pi over 2, so that's pi over 2x. Plus c, and c was pi over 2 as well. And then plus d, and d was our vertical shift. So vertical shift is d in this equation, so that's minus 1. We're done. Okay, write an equation of form a cosine bx plus c plus d. So let's look at this graph again. Notice it is looking like the original cosine in standard form, so there's no phase shift right here for the cosine. There's no phase shift. So phase shift is equal to 0. B we know was pi over 2. That means we need to find c. Again, phase shift is negative c over b. 0 for the phase shift times any number gives you 0. So negative c is equal to 0. So c will be equal to 0. Now we have enough information to write our equation. Our equation then will be y is equal to, or f of x will be equal to 2 cosine b was pi over 2x, pi over 2, sorry, then there's an x. C is 0, so plus 0, then minus 1. All right, so, and that is our answer. Let's look at number 21. Find the sides A, B, and C to the nearest tenth of a meter and the measure of the angle alpha to the nearest tenth of a degree. Okay, so let us start by trying to find A. And trying to find A, we look at this triangle right here. And in this triangle, we have 8.1, we have 42 degrees, and we have A. 42 degrees is opposite to 8.1, and A is adjacent to that 42 degrees, so therefore we can think about tan. So tan of 42 degrees is equal to opposite over adjacent, so that would be 8.1 over A. You switch this around a little bit, doing some algebra, A will be equal to 8.1 over tan of 42 degrees. If you plug that in your calculator, you should get 8.999 something, so that would be around 9 meters. We're trying to find B. B is going to be the same triangle. B would be the hypotenuse of this triangle, which includes 42 degrees. We could use a trig function. Alternatively, since you now know A and other side, and you're looking at a right triangle, you could also use Pythagorean theorem. But let's use a trig. So B is your hypotenuse, and 8.1 is your opposite side. Therefore, we can think of sine, because we have opposite and hypotenuse. So sine of 42 degrees is equal to the opposite side, which is 8.1 over B. In some algebra, B will be equal to 8.1 over sine of 42 degrees. You plug that in your calculator and round it around. That should give you about 12.1 meters to the nearest tenth of a meter. Then we need to find C. Okay, so C, we're thinking about a bigger triangle. Now, we're thinking about the bigger triangle. It's really a bigger triangle. All right. Because C is a part of this long length, which includes A, we got to think about how to find this, right? You know, the hypotenuse of this big triangle is 19.1, and this other part is 8.1. So if you do 19.1 squared, if you're using Pythagorean theorem, right, so A plus C be equal to the square root of 19.1 squared minus 8.1 squared. Righty? And so we could say that C now be equal to radical 19.1 squared minus 8.1 squared, all of that minus the value that we got for A right here, which was about 9 meters. Okay, so let's work this part down. So that would be plugging it in for A minus 19.1 squared minus 8.1 squared of that minus 9. Put that in your calculator. You get that C would be about 8.30 meters, right? 8.3 meters. Right. Okay, the last thing we want to find is our angle alpha. Right here. But we know two sides of this right triangle, the hypotenuse and the opposites. So you could do sine of alpha equals opposite over adjacent. So that would be equal to 8.1 over 19.1. Then if we take arcsine both sides, so arcsine of the sine of alpha is equal to arcsine 8.1 over 19.1. So that means alpha be equal to arcsine 8.1 over 19.1. And that should give you 25.09 degrees. Right? 5.09 degrees. Or you could say that's 25.1 degrees. That's your answer. Okay, thanks for watching.